Hello everyone, this is Batmalata, Science faculty. Do not dwell in the past. Do not dream of the future. Concentrate the mind in the present moment. In this session, we are going to discuss about equation of motion. So, we are going to derive this equation of motion with the help of the graph. This is nothing but the velocity time graph. It's the plot between velocity and time. Here the 0 represents the initial position. The person is about to start. When he is starting, he is about to move to the initial velocity. He is moving with initial velocity u. Okay. So later on, he gives some acceleration. He gradually increases its speed. So we can say he has given some acceleration and he has reached the final point x. So what's the velocity? Final velocity. Okay. So when a person is traveling from one place to another, there exists an acceleration. Acceleration exists means there will be a velocity. So the destination is the final velocity and the starting position we consider it as the initial velocity. Okay. So now let's see the overall view of all the three equations. Then we can derive each and every equation. Right? So first equation is V is equal to U plus AT. Our first equation of motion is V is equal to U plus AT. So here V represents the final velocity, U represents initial velocity, A represents acceleration and T represents time. If you see this first equation of motion, it gives the relationship between velocity, acceleration and time. It shows the entire combination of velocity, time and acceleration. And this first equation of motion can be derived with the help of the graph. By taking the slope, we can derive this first equation by taking the slope of the velocity time graph. Next is the second equation of motion. Second equation of motion, it denotes S is equal to ut plus half at square. S is equal to ut plus half at square. S is the displacement, u initial velocity, t time, a acceleration. So it gives the relationship between displacement, velocity, time and acceleration. And this equation can be derived from this graph by taking the area of velocity time graph. So here we can take the area OUXT. We can take the area OUX and T. If you see this area, it forms the model of a trapezium. So we used to derive with the help of the trapezium formula. Okay. The third equation is V square is equal to U square plus 2AS. We know V square is equal to U square plus 2AS. So V represents the final velocity, U represents initial velocity, A acceleration and S it is the displacement. So this third equation of motion, it gives the relationship between velocity, acceleration and displacement. If you see this first equation of motion, when you take the slope of velocity time graph, it represents the acceleration. If you take the slope, this red line denotes the acceleration. Okay. Then the second equation of motion, if you take the area of this velocity time graph, it represents the displacement, the shortest path he has travelled. And this third equation of motion can be derived from the second equation of motion. Right? Now let's see how to derive this. Now let's derive first equation of motion. We know first equation of motion is V is equal to U plus AT. So how shall we derive? We have to take the slope from velocity time graph. So here, which forms the slope? This u, x, y. It forms a triangular shape, right? It forms a triangular shape, u, x, y. Okay, from that we are going to extract this triangle from that graph and I have drawn here. So if you see the triangle u, x, y and this is the angle theta. Okay, if you see the triangle, this part is the hypotenuse, this part is the adjacent and it is the opposite. We have learnt many trigonometry formulas. So here for this triangle u, x, y, we are going to take tan theta. Why? Because I am not going to consider this hypotenuse part. I need the adjacent part as well as the opposite part. So I am going to take the tan theta. So in triangle UXY, this tan theta is equal to opposite by adjacent. It's nothing but the trigonometry formula. Tan theta is equal to opposite by adjacent. Now see the value of opposite x, y. So opposite value is x, y. Adjacent u, y. So adjacent value is u, y. So tan theta is equal to x, y and u, y. So I have informed that the slope of velocity time graph, it gives you the acceleration, right? So here this angle, what does it tell us? Gives the acceleration, right? This red line, it is representing the acceleration which provides an angle theta. So this tan theta, it is given by the acceleration A is equal to xy. Now look at the graph xy, x and y. What does it say? It gives the velocity, right? So whenever we calculate the velocity, we subtract from final to the initial. So final velocity minus initial velocity, that is v minus u. So final velocity v minus initial velocity u. Uy. So what does the uy say? It is just parallel to time, ot. So we can denote as t time. Uy is t time. So a is equal to v minus u by t. This denominator t, when coming to the left hand side, it becomes multiplication. So at is equal to v minus u. It's just a simplification. Okay. At is equal to v minus u. And minus u in RHS, when it is shifted to the LHS, it becomes plus u. So u plus at is equal to v. So what's the first equation? V is equal to u plus at. Just by rearranging, we have got this first equation of motion, v is equal to u plus at. For this, we have to take the slope from the velocity time graph. Now let's see the derivation of second equation of motion. We know that second equation is s is equal to ut plus half at square. So we can derive this from the velocity time graph. So how can we do it? We have to take the area of velocity time graph. So here we consider the area O, U, X and T. If you see this O, U, X, T, it forms the shape of a trapezium, right? So I just extracted this trapezium out in this elaborated manner, right? So the trapezium O, U, X and T. So we know the formula for the trapezium. We have learnt in mathematics, right? So what is the area of trapezium? Half into sum of parallel sides into height. So that's the formula for the trapezium. Okay. So I have said that this area of trapezium, if we take the area of trapezium, it represents the displacement. It shows the shortest path to travel the destination. Right. So if you see, we just take this as displacement is equal to area of trapezium. So this displacement is given by the letter S is equal to, what is the area of trapezium? What's the formula? Half into sum of parallel sides into height. Okay, so S is equal to half sum of parallel sides. So now you just consider OU. What is the OU? Initial velocity U. X and T, it forms the final velocity V. So this forms the parallel sides. This forms the parallel sides. So OU, it is the initial velocity U, and another side, sum of parallel sides, so OU and XT. So OU, it is given by initial velocity U, and XT, it is given by the final velocity V. So U plus V. Sum of parallel sides is U plus V into height. What is the height? It's T, time. So height it is given by time T. So we got the variable S is equal to half into U plus V into T. Now we are going to substitute this V from first equation of motion. So what is the first equation? V is equal to U plus AT. So we are going to substitute this V from first equation. So S is equal to half into U plus V. So V, instead of V, we have replaced as U plus AT into T. Next step, S is equal to half into U plus U becomes 2U plus AT into T. Now I am going to multiply this T inside. So S is equal to half into 2U into T, 2UT, AT into T, AT square. So 2T, when it is multiplied, it becomes AT square. Now you just make this half inside the bracket. So S is equal to 2UT divided by 2 plus AT square divided by 2. 2 and 2 get cancelled. Here it remains as it is. So S is equal to UT plus AT square by 2. So now just rearrange it. S is equal to UT plus half AT square, from which we have derived the second equation of motion. For second equation of motion, you have to take the area of velocity time graph. Now we are going to derive the third equation of motion. To derive this third equation of motion, we are going to take the equation from second equation of motion. So S is equal to half into V plus U into T. This is the equation we got after extracting the values of the area of trapezium, right? S is equal to half into V plus U into T. Here we are going to substitute the value of T. Okay. So for third equation of motion, we have to substitute the value of T. Okay. So here this value of T is taken from first equation of motion. V is equal to U plus AT. So here we are going to extract this T value. So V is equal to U plus AT. I am going to take this U from RHS to LHS. So V plus U becomes minus U. V minus U is equal to AT. I need this T alone. This A becomes division when it is changing its sign. So T is equal to V minus U divided by A. So we have extracted the value of T from first equation. Now substitute this value in this equation. S is equal to half into V plus U T. Instead of T, we are going to substitute this value V minus U divided by T. Okay. So now see here, I have given V square minus U square. How did you form this? We have an algebraic equation. A plus B into A minus B is equal to A square minus B square. Right? We have an algebraic formula. A plus B into A minus B is equal to A square minus B square. Here A is V and B is U. So instead of A and B, just substitute the value V and U. So A square is V square minus B square is U square. So V square minus U square. So S is equal to half into V square minus U square divided by A. Right? So now just multiply it. S is equal to V square minus U square divided by 2 into A, 2A. I am just taking this 2A from denominator to LHS. So 2A is equal to V square minus U square. So this minus U square, when it is coming to LHS, it becomes plus U square. So 2AS plus U square is equal to V square. Just to rearrange it, V square is equal to U square plus 2AS, in which we have got the third equation of motion. Just a slight difference is, from this equation, if you substitute the value of U, you will get the second equation of motion. If you substitute the value of T from first equation of motion, you get the third equation of motion. This is the slight difference, right? So our three equations of motion are V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. So today in this video, we have discussed the equation of motion and we have derived all these things, right? Let me see you in the next video. Until it's bye bye and thank you.